Morning, everyone, and welcome to the first masterclass of Cluj Innovation Days 2021. It is my privilege to open this year's conference with this session about DevOps, a topic that is very dear to me, and I hope you will enjoy the topic and hopefully engage in a conversation around this. My name is Ciprian Sorlea. I'm a CTO, Chief Technology Officer at NordLogic Software, a product development company born and raised here in Cluj-Napoca, the home of Cluj Innovation Days. And I'm also a Vice President of Cluj IT Cluster. Today, we are going to be talking a bit about DevOps. Like I said, the topic that I care a lot. And in order to make sure that the session is going to be optimal for you as the audience, I would kindly ask you to use the chat section in the event in Hopin to let me know or let us know a bit about your background, a bit about your current interest and the current exposure to DevOps practices. So just let me know if you're a business person interested in DevOps, if you're a developer, if you're a technical person in general, or more interested to introduce DevOps in your organization. So feel free to use the stage chat section to put in your questions and also your thoughts about this. Without further ado, I'm going to share my screen and we're going to jump straight into the presentation. Okay, so from zero to hero, driving your organization into the DevOps world, right? Assuming that some of you might actually not start from zero, many of the things that we are going to be discussing today are still going to apply. So enjoy the next couple of slides. Let's start with the most important question. What really is DevOps? This is a term that has been circling around for many years. Many organizations, just like Agile, have tried to embrace it and adopt it, but there's a lot of debate regarding what DevOps truly is. And we can ask ourselves, is DevOps actually a process? And up to some extent, it is. Up to some extent, if we think about what the process is, the fact that it has multiple responsibilities, it has multiple actors, people that are actually doing a lot of things, and a lot of things are happening kind of automatically. Yeah, it is a process, but it's not just that. Because ultimately, if you just establish the DevOps process in an organization, it's not going to help significantly. It's not going to be any different from any other IT type of processes that you might already have in your organization. Is it a technology? Well, DevOps, just like anything else in the software industry or the software world, relies on technology, relies on other tools and applications to be available. But again, throw a bunch of applications and a lot of software and a lot of tools and a lot of technologies to your teams, and they are not going to be DevOps oriented. They are not going to your organization is not actually going to be a DevOps organization. Is it a role? Is DevOps a role? Many organizations are trying to place the DevOps responsibility on dedicated staff, on dedicated people. So they define this really big job description where a lot of technologies have to be known and a lot of practices have to be adopted by individuals. But is that actually going to help? Is that the way DevOps actually works? You just define a role, a job description, you assign it to some people in your team, in your organization, and boom, you're there. I don't think so. Is it a practice? Is it something that if you start doing in your organization more and more is going to help your organization? Well, here the answer starts to be yes. While the other questions were also, the answer to the other questions was also slightly positive. This is clearly positive because it is a practice that needs to be propagated in your organization. It is a suite of practices. Ultimately, DevOps is a set of principles and practices that are adopted by organization in order to deliver software faster. So yes, it is a practice or a set of practices that we need to be looking into. Is it a mindset? And this is where DevOps truly becomes interesting, or the concept of DevOps really becomes interesting, because it doesn't imply that if you have a job description and have some tools, you're DevOps. If you don't have the DevOps mindset, if you don't think about what DevOps really is and how DevOps really should help your organization and your product and your team. So it's you as an individual, you need to have the right mindset and to think about how you do things the right way in order to call yourself a DevOps engineer or whatever you are. Is it a culture? And yes, the answer here is definitely yes. You cannot be a DevOps organization. You cannot say about yourself that you're applying DevOps and you're using DevOps or whatever how you want to use that term if you only have individuals in your companies that are in your company, in your organization that is investing in that. If you bring a person that has the DevOps mindset into your organization, doesn't turn your organization into DevOps unless that mindset is spread out in the entire organization. And that's what defines the company's culture. So you as a business owner or a manager or whatever your current responsibility is, in order to fully embrace DevOps, you need to make sure that becomes part of your culture. Why is actually DevOps important? So we see that now, we now see that it's not just a technology, it's not just a practice, it's way more than that, and needs to be at the entire organizational level. But why will you do that? Why will you invest in that? The first thing that any organization that starts to apply DevOps practices and to become a DevOps organization acknowledges and recognizes that DevOps improves development and delivery speed. Things get to be delivered faster. Your products and your services are available to your customers much faster than before. And you start to get traction based on that. To give you an example, I used to work in an organization many, many years ago, and the organization was delivering their product once every 2 years. Insane, right? And when I joined that company, I set a goal to myself and my team, and I said, we are going to make 10 releases per day. Everybody called me crazy. But in 2 years' time, we got to the point that we were able to deliver every other week a really functional product. And that was a significant gain, right? A significant improvement in speed of delivery, right? Nothing like that was ever before available or applicable in that organization. So 2 years to 2 weeks, it's a huge difference. And that's what DevOps can do for you. It improves development and delivery stability. That's another important aspect of delivery, right? You can release really often. You can push your products and your services, update them and release them to your customers, but have a lot of issues, have a lot of defects, have a lot of problems. And DevOps as a concept says, okay, speed is not enough. It also needs to be stable. So you also need to make sure that release after release, the functionality that you deliver to your customers is actually having the right stability, it has the right quality. And DevOps delivers to that. It maximizes efficiency because, as we will see further down the road in this presentation, it automates a lot of things. And then mistakes are no longer going to be made, and a lot of processes and a lot of steps in your development processes are going to be automated. Therefore, it's going to be extremely efficient to work and to deliver things to your customers. Ultimately, the speed comes from this efficiency, right? You cannot be fast if you're inefficient. So this goes hand in hand. It reduces costs, and you will see this asterisk here, because it reduces the cost eventually. It doesn't help you cut the cost significantly from day one. So those of you who are looking to shave 50% of your development costs or your operational costs from day one by adopting DevOps, it might not be the case. You need to have an initial investment. You need to go through a series of stages before you reach that level where DevOps is actually helping you to reduce the cost significantly. Just like everything else, first is going to be worse before it gets better, right? First, you need to fix a lot of things, address a lot of things, invest in many things before you start to get the results. One of the things that DevOps as a culture, if you want, as a methodology, just like Agile and other quality-oriented and delivery-oriented practices and methodologies, is improving is quality. So quality is at the centerpiece of agile methodologies and as at the foundation of the DevOps mindset. You don't deliver fast and efficient if you don't deliver quality, because ultimately what you do and what you're working on as a DevOps team is to make sure that you increase the quality while you also increase the performance, the efficiency, and the speed of your delivery. If you deliver feature faster to your customers, if you deliver better features with higher quality that are going to work seamlessly for them, and they are going to be able to use more and more capabilities that you expose, what do you guess? What do you think? Your customers are going to be happy. So DevOps helps also to improve the customer experience. Not by itself, of course, because customer experience looks into many things. But if we split, if you want, what the customer experience really means, it has a lot to do with the quality, not just the functional quality of your product, but also the non-functional qualities, such as performance and availability and other things. And all those things are going to be helped by the DevOps approach. Okay, let's have a look into a couple of perspectives, if you want, a couple of things, a couple of concepts, a couple of ideas that are influenced by the way you apply DevOps and use DevOps in your organization, and also is impacting the way DevOps is actually done. So it's kind of, if you want the cat and mouse game, you cannot have one without the other. DevOps is going to support those things, those perspectives, but also those perspectives are fundamental for DevOps engineer or a DevOps practitioner to understand. In other words, we need to consider all the hats that we need to have as a DevOps practitioner, as a DevOps engineer, as a team member that works in a DevOps team or DevOps organization, in order to be successful, in order to be able to deliver on those promises: quality, efficiency, speed, and so on. And the first thing we need to be considering is the organizational type. How is our organization modeled? Is it an enterprise? Is it a governmental organization? Is it a startup? Different organizations have, different ecosystems, different cultures, and as DevOps engineers, we need to understand how that organization is going to help us, support us in the DevOps direction, and how that organization might actually limit our ability to deliver. In other words, if we work in a startup organization that is cloud ready and is cloud friendly and wants to go full speed with DevOps, we start from scratch, then there is very little, if you want, there are no breaks in our adoption of DevOps practices. But if we work in a company organization with many regulations, with many restrictions, either by law or by business requirements or whatever those breaks might be for us, we are not going to be able to adopt everything from day one. We are not going to be able to use everything that we see on conferences and people are talking about. So we need to really understand our organization before we do anything else. It's not like you hire somebody who's an expert or managing networks, and then you have DevOps and you can do anything you want. You need to collaborate with that person and make sure that that person understands exactly how what's the type of your organization, and it works with you. That person works with you. That network engineer or ops engineer works with you to make sure that it starts with where you are and is taking you to the DevOps, world, but with the constraints that you have in your organization. Software development lifecycle and also the development stage you're in is crucial for DevOps engineers and DevOps practitioners to really understand how they can contribute to the product. Whether you're using a waterfall methodology, or you're using Kanban, or you're using Scrum, all these methodologies and all these practices and all these types of development are influencing the way your company currently delivers. And DevOps needs to be aligned with that. You cannot have continuous infrastructure upgrades and updates if your applications are released every 2 years. You cannot have infrastructure that is unmaintained for 2 years if you try to release every other day or multiple times a day. There are things that have to be synchronized. Delivery of the product needs to be aligned with how that product is being supported by your infrastructure and by your operational side. Architecture. Many times, it is said that architecture is being managed and directed by architects. I've been doing architecture for many products, and it is usually said that DevOps should not worry about architecture, and I strongly disagree with that, because it's one thing to prepare the DevOps part of things for an architecture that resembles something like you see now on the screen, versus something simpler and easier like that, right? You don't shoot the fly with the cannon. Therefore, you need to adapt your practices to your architecture and to your product type. Therefore, it's important for DevOps to really understand differences in different types of architectures, in different types of software design systems. Whether it's a monolith application or it's a microservice-based application, a service-oriented, serverless, if it uses platforms as a service, if it uses just cloud services, generic cloud services, they're all important part of how the DevOps strategy and how a DevOps engineer should work. And of course, we need to look at the same with the same eyes at infrastructure. Going with something that this resembles an on-premise kind of deployment, and we might say, well, this is really complex and it's really complicated from the infrastructure perspective. But actually, this one is more complicated because it involves more external systems than the previous one. So complexity of the application, complexity of the infrastructure is something that impacts the way we do our DevOps and the practices that we adopt, but also needs to be setting the expectations for what the DevOps should know and what they should be doing in your team. Functional requirements, usually in many teams prior to DevOps adoption, many teams involved IT operations into some of their products just to make sure that they deliver the machines and they deliver the databases specific to the product that another team is building, the development team is building, right? And this doesn't work. You might say, well, what do they have to do with what we're building? They are just ops, right? They are just network guys. They are just infrastructure guys. What should they care about the features that we are building? Well, here's the thing. If you understand even as a simple network engineer, right? If you understand how that feature is going to be used and who the users are and what are their needs, you can come with more feedback and with more support and with more value to that team and to that product. If you know the user, if you know the features, if you know how those features are going to be used by the given users. So functional requirements, while being something unrelated apparently to DevOps, I believe it's really important to be put into the same basket, to be put into the same set of items or things that are related to DevOps and are important for DevOps. And then we go into the non-functional requirements. And what's the difference between functional and non-functional? Think about functional is the car. You buy a car and you want it to be fast, and you want it to be really good looking, or have many horsepower, or I don't know, whatever defines the car of your dream. But then non-functional is the road, is the part that you don't want to think about, but ultimately defines how your experience is going to be. If you have a really expensive car, but the road is crappy and full of bumps or holes, your driving experience is going to be bad. So it doesn't matter how good your car is if the road that is supporting that is unmaintained and unusable. So non-functional requirements are all those little things that maybe we as users don't want to think about, but when they are not taken care of, we suffer. One of those things is security. And in a DevOps organization, everybody in the team, everybody working with the product needs to understand the security requirements, needs to understand, especially today in having everything exposed to our users is opening up a lot of potential issues, a lot of potential security gaps. And if we only have one person that is assigned to maintain security, to maintain the gate, chances are that that person is going to miss something are quite big. If you put security in the hands of everybody and make sure that everybody is at least aware and working towards ensuring security for the application, your security standards are going to go higher and higher. Of course, you still need dedicated professionals. You need to have people that are specialized in security, but that kind of knowledge needs to go throughout the entire team, not just for one person, right? Think about DevOps is not just a single role. This facet of DevOps and security in general is not something that just a single person needs to have. You might have an expert in the house, but it needs to be something that is used and worked on by everybody in the team. Same thing with performance. Performance is critical as a non-functional requirement to the applications that we build. And it has to be aligned with customers' expectations, with industry standards, with many things that many items that can hint the kind of performance we need to have. And DevOps engineers need to be aware of all that. Needs to understand what is the latency that an application should have, what is the response time, what is the throughput, how many requests an application should provide, right? It's extremely important that everybody knows, not only from the infrastructure perspective, but also from the development perspective and building the solution, how fast that application needs to work and in which condition. Not just, we often see situations when customers come and say, I need a fast app. How do you define fast? Is it a Ferrari fast, or is it a Porsche fast, or is it a Tesla or spaceship fast? What defines fast in that organization? How is the performance actually defined? And this needs to be detailed and then spread it through the entire team to make sure that everybody works towards the same performance goals. Scalability, right? How much do we need to scale? As developers, but also as infrastructure engineers, so in general as DevOps engineers, we need to make sure that we understand how our application is supposed to scale, how our application is supposed to grow from running on a single machine to maybe 20 machines or maybe 1,000 machines. Are we ever going to need that or not? Where are we from the scalability perspective? How many users are we going to have? How much do we need? How much data are we going to have? All those things are really important questions that the DevOps team needs to ask, and the team as a whole needs to work towards. It cannot be something that is just, a simple requirement, say that somewhere we are going to build a fast application. It needs to be detailed, and it needs to be used in any or supported by any practices that we are adopting. Availability, right? How much downtime can we afford? Are we an application, or are we building an application that if having a downtime of 10 minutes is going to cause significant issues, or we can afford taking 2 hours every day of downtime for maintenance and upgrading? Our DevOps efforts should be correlated with that, should be aligned with that. If we have that luxury, if we have a 2 hours downtime window every day, then our life is extremely simple, and our upgrades, procedures, and everything can be really simplified. But if we cannot afford more than maybe 5 minutes per month or per year, and there are systems such as, for instance, Google's infrastructure, a really small downtime of a couple of hours that in a time scale of a year was less than 0.01%, impacted hundreds and thousands of companies and organizations, especially now in the pandemic time when all the kids were online with Google Classroom. They were heavily impacted by the downtime. So if you have many users, if your application and company is used at scale, then your availability needs to be extremely high. If, on the other hand, you have an application that uses internally or is used only on specific time zones, and when that time zone goes to bed, you have the luxury of being able to run maintenance work on your application, then your availability requirements are much lower. All the effort needs to be aligned with that. DevOps, development, operations, even other types of efforts such as marketing needs to be aligned with your availability requirements. Capacity is aligned with performance and scalability up to some extent, meaning that you need to understand how much you have to be able to handle at a given time and how much infrastructure you need to have. So it's helping you to plan ahead for spikes. It's helping you to plan ahead for events that are going to cause an increase in load in your application. You need to do some simulations. All that part needs to be part. All those things have to be part of your DevOps approach and your DevOps strategy. Observability. It's a really nice term that actually incorporates more elements of DevOps, and they are most of the time familiar to those that have history in ops, in operations. Basically providing dashboards that give you visibility into your application, into your system. And that dashboard or those dashboards should make sure that include things like logs, so you understand how your applications are behaving. They should include metrics, so you also understand how the different processes and different actions in real time are being performed, or the results of those actions. You should be able to have events so that you measure and monitor certain situations, maybe exceptions or conflicts or errors that you might get into in your application. So being able to bring all that from your entire application into a centralized dashboard and to also set up alerts and other things is key to applications and to teams and organizations that want to deliver faster and to be able to react quickly to change. Observability and all these things that I mentioned are basically your compass. If you're a sailor going on the trip on the sea, if you don't have a compass, if you don't have a navigation system, you're going to be lost. And observability non-functional requirements are actually establishing and allowing you to understand as a team, not just DevOps engineers, but as a team and as an organization, how you can make sure that you're not lost at sea. How can you see in your application, inside your application, and understand how your application or your systems are behaving to be able to react and address any given issue. Manageability is related to observability, but it provides, it's basically the other side of the coin, if you want. Once you know what is wrong with your application or what needs to be done with your application, maybe you have a spike and you need to be able to increase the allocation of the resources for your product, you need to be able to perform those or to add those resources. And how easy it is to add those resources, how easy it is to manage your infrastructure. Can you afford to wait 2 more weeks for a server to be delivered to you so that you increase your capacity? Or is it going to be just a click of a button to increase that capacity? Or is it going to be an elastic and auto-scaled infrastructure that will accommodate the new influx of users and the increased traffic, and is going to scale automatically up when that event is occurring, and scale down to save resources when those users are no longer hitting your application, right? How easy it is to change the configuration and to change the behavior of your application is also not only a development question or a development issue or a task, but it's a DevOps question in general. So you need to think about how infrastructure is going to be configured, how is it going to be to add new firewall rules, how is it going to be to add, new ports, VPN connections. Anything that can be related to your application is part of defining the manageability requirements and understanding how easy it can be or should be to perform those operations. Reliability, I think it's a no-brainer that in today's world, we need applications to be stable, we need applications to be reliable, we need applications to survive an incident and to be able to carry on with their activity. We need to make sure that our applications are reliable. Otherwise, trust is something that is gain really hard and it's lost really easy. If we lose our customers and our users' trust, our reliability, then we might lose those customers forever. So it's important then that our applications and our systems are built in a reliable fashion. Of course, there are exceptions. When you are a startup and you don't have yet users, you're not going to focus on reliability so much because you want to have quick validation and you want to iterate fast, and then hardening and making sure that everything is as stable as possible might not be your first interest. But once you go beyond the MVP, once you reach a stage of more maturity, then you should be investing into this reliability, and your team with those that have and are responsible of practices that are related to DevOps should be aware of your reliability requirements, increased reliability requirements, so that they deliver on those requirements. Recoverability, that's a mouthful. It's another important NFR that DevOps engineers have inherited more from the ops, let's say, side of things. Being able to survive catastrophes. IT engineers, old school IT engineers know that bad things will eventually happen and they need to be prepared. It's probably one of the first risk mitigation strategies that any old school IT organization is going to have already deeply embedded into their systems. How do we recover from a failure? How do we recover from a catastrophic event? And having backups, having disaster recovery plans, having another copy of the same application or the same infrastructure even running somewhere else at a different provider is, for many organizations, a key. And this needs to be not only an IT specific concept or something that only network engineers or system engineers are worried about. This needs to be something that as a company, we need to understand what is our policy, what is our vision, and what we need to do to deliver on those things. Testability. This is somehow development related. We believe that, or IT engineers believe for many years that the developers or the development team is the one that is building the application. They should be testing it. We don't care about that. We should be just installing it, shipping it to our servers, and that's it. That's where our responsibility ends. But it's not working. And the reason that is not working is because most of the time, the infrastructure needs to be built in a way that the application can be tested properly. You need to make sure that it's not just you run it on your local machine and then you deploy it to production. You need to have multiple environments that have to be synchronized, that have to be aligned. And to be able to do that, DevOps organizations need to understand all the different types, and we are going to cover this briefly, all the different types and types of testing that can be applied, and how we can ensure that different components, different parts of the system are testable. And believe it or not, it's important to make sure that even your infrastructure is testable, even your infrastructure upgrades are testable, because that's ensuring that the process is repeatable and you're able to deploy it with confidence and therefore reduce the risks of incidents showing up only in production. Excuse me. Let's talk about DevOps practices. Ultimately, these are the things that are helping any organization to really start embracing and onboarding on their path towards DevOps. And the first and most important thing, besides having people that are working on infrastructure, is automation testing. You cannot deliver fast if you need to have people doing manual testing in that process. That's a no-brainer, right? If you want to deliver fast, that delivery process needs to be seamless and needs to be automated. And that implies that in every single stage, you do automation testing. You test automatically code that tests other types of code or other type of code automatically. And we have different types of testing. We have unit testing. Unit testing is a simple concept and basically says, okay, if you take a single unit, it can be a method or a function, you need to test or build a number of tests that are going to take that unit of code, functional unit of code, through all the different paths, all the different routes that the execution can go, and make sure that you validate the outcome of that function. So basically, you have the input data, you have the actual parameters, if you want, and then you have the outcome, and you need to make sure that the outcome is the expected one. Excuse me. Unit tests are cheaper to build and cheaper to execute. You can have hundreds and thousands of unit tests in your applications that are running in milliseconds or seconds, and therefore your chances that you're capturing every single potential issue is quite high. Now, unit testing is not enough, and unit testing needs to be extended by feature testing, because units can work really well separated, but when you try to put them together to deliver a specific functionality and to give you a specific outcome, you need to test them together. That's when you start testing features as a whole, not just units of work, not just functions and methods. And this is basically a crash test, just like the picture nicely depicts here. And it shows that for the way the feature was designed, the system works as expected. When working with web applications, and today almost any application is using what's called an API, an application programming interface, a web API, basically, or REST API, if you want. And that allows not only front-end applications such as mobile or web to integrate with the backend, but also allows other integrators to consume that API and to build other products and to build integrations. Now, if you have an API that is provided for your application, and especially if it's provided for others to be to use it and to integrate it, it's extremely important that you also double that API with specific API tests. And that the API is actually just ensuring that the API tests are just ensuring that your API is following the contract, right? That interface that you have designed, which relies on maybe some URLs and some methods, HTTP methods, and some headers and some query parameters, all those things that are defining the REST API, that needs to be tested. That needs to be, they have to be tested, right? All those items have to be validated that they adhere to the contract that was defined for that interface. Even when the interface is not a REST interface, you can still leverage specific tools for that technology or for those protocols and have API testing. So even if your API is not RESTful, you can still leverage API testing. Integration testing is extremely important in systems that use multiple services and components that are together are being assembled for a specific application or product. And it basically ensures that not only individual features are working, but end-to-end, your system is properly integrated. All the systems involved, even third-party, are responding correctly to different requests, to different scenarios. So understanding how those systems come together, how those components and services come together is extremely important. Now, we started with unit tests, which are really easy to build and easy or fast to run. But if we look at things like, as we go from unit tests to integration tests, things get to be more and more complex, more complicated, and more time-consuming. And usually, you want to focus on making sure that you have integration testing and you have API testing for the areas that might not have been captured by the lower level type of testing that you use. So if you cover the functionality, or you're sure that certain behaviors have been tested using unit tests, make no sense to double them with integration tests and with other things. You should be focusing at different facets of the problem, not test a specific granular functionality, but make sure the end-to-end functionality works in the system. And of course, you can also do dedicated UI testing, whether it's web or mobile, ensuring that you're trying to replicate the way a user will click the buttons and view the content and access your application, whether it's mobile, web, or desktop. It's adding another level of quality. Of course, UI testing is usually the most expensive to be and more time-consuming type of testing, but the benefits are huge because it allows you to make sure that significant errors are not going to slip and end up into in front of the user. Another practice related to testing, if you want, is the automated code review, but that doesn't test the actual functionality, but it rather tests the code. Companies are using different or might have used other practices such as code reviews, manual code reviews, where developers are reviewing each other's code, and that's extremely valuable and extremely good practice. And I suggest everybody is embracing that as much as possible. But it should be doubled by automatic code review, because automatic code review with, for instance, static code analysis enables you to check items that might slip the attention or the perception of a specific developer. Can also check things like security, code smell, vulnerabilities, and other areas. This is an example from a project that is using Sonar. And we see that early in the project, when the project was added, it spiked at some point. You see here in this corner, it spiked in terms of number of issues or code smells. It wasn't big, it wasn't a big issue, but as soon as we noticed that, we identified what the problem is, and we were able to quickly address that, so that that service, that application, is going to be much better prepared for the future. Why is this important? Because later down the road, that service is going to be easier to be maintained, and that later down the road, that service is going to have less issues because we made sure that any potential problem was identified early. So automatically reviewing the code, doubled by the manual code reviews and peer programming, is extremely valuable to make sure that the code by itself is having as little problems as possible. Now, even if you have unit tests, which is improving the quality significantly, having automated code reviews and static code analysis is extremely important. Another type of automatic code review is what is called linting, and it's basically making sure that small nuances that are maybe specific to the language. If you use C# or TypeScript or JavaScript, there are certain things that might be different between those languages. And when you switch a programming language, you might be maybe you might use something, one practice or another that you were familiarized with in another technology, in another programming language, but it doesn't apply or it's not recommended for that language. And linting is usually a process that allows you to quickly scan those kind of things. It's not a security issue, it's not a code defect, but maybe how you order your functions in a class is differently or has different recommendations in one language to another, or is adhering differently to one coding style for one specific team than another. So linting and style checking is ensuring that your code is actually also going to be adhering to the practices that the team adheres to the standards that are recommended maybe for that particular technology, for that particular language. So by combining linting, style checking, and static code analysis, you can make sure that automatically, without a human interaction, you get almost all the issues to the surface as soon as possible so that they can be addressed. How is automated testing and automated code review actually brought together is through continuous integration. Continuous integration is the practice of making sure that everything that you build as a team eventually integrates into something that was previously built while maintaining the same level of quality and the same adherence to practices and to standards. In other words, it's almost like that philosophy that, when you go outside to a forest and you make a barbecue, or you just, enjoy the weather and the nature. When you leave that place, you should leave it cleaner than you found it. Right? It's almost the same thing here. If you want to integrate with not with the nature this time, but with your product, you need to make sure that after you build something, you deliver something, you leave that product in a better shape than it used to. So making sure that the functionality was not broken, that the practices, the coding style, and the code quality has not been affected. Those are things that have to happen every time we build, every time we work on a new feature. And that's usually done with the continuous integration. Tools like Jenkins, Azure DevOps, GitLab, and others are ensuring that every time a developer is pushing the code into a source code repository such as Git, Bitbucket, or others, so every time that action happens, every time the developer is pushing the code, all those tests, all that automated code review is automatically applied on the new code. And in case there is any issue, that code is rejected, so that the developer gets the chance to review what was found and to address that and fix that immediately, rather than finding that issue in production 5 months from that point when a user is actually accidentally hitting that use case. So it shortens the time between when the issue was introduced to when the issue was found. And because the developer committed the code and got the feedback that something was broken in maybe 5 minutes, that's the standard or maximum time allowed for a continuous integration process to be performed in. So if the user got that feedback in less than 5 minutes, chances are that he hasn't yet switched the context, hasn't yet moved on to another task. So he knows immediately what is wrong and he can address that problem. Now, if that problem is only found 6 months later, accidentally by some user, maybe that developer is no longer in that team, maybe he's moved to another project. So try to figure out, bringing somebody else into the picture, trying to understand what is wrong. Right? So this is where continuous integration actually helps us capture everything as early as possible into our development process, and to make sure that we are continuously improving and at least maintaining the quality of our product. And this is done through a simple multi-stage, if you want, process where we have the checkout, where we the CI pipeline, that's how it's called. The CI pipeline is just checking out the source code from a given repository, and it's building the code, making sure that there are no compilation issues and so on. It's testing, and in testing we can have unit tests, API tests, all types of testing that are specific to a single service or a single component, and also runs the automatic code review on top of, or linting or static code analysis on top of that service or component that was just modified. Then it packages that unit, that service or component, and it's shipping it to be released. Packaging can take different forms depending on the technology. For most common, for instance, if you're building web applications, you might ship NPM packages that are then going to be included in different parts of your application. So you build components and then they are packaged as NPM packages. If you're a Java developer, then maybe you're familiar with Maven, or you should be familiar with Maven. If you're a .NET developer, you're going to be producing NuGet packages. But if you're building applications or services that have to be deployed and to be running somewhere, most likely you're going to use something like Docker, because Docker is allowing you to incorporate your application along with all their dependencies in a simple unit that is going to be able to run anywhere. So packaging the application in the right format is crucial for a good DevOps strategy. And of course, releasing means that you put that artifact, that package that you just built, into a repository. And depending on the artifact or the package type, you need to pick the right repository. If you have a NuGet package, then you can either push it to the official NuGet repository. You can use your own, such as Azure DevOps, or you can also use Nexus or other technologies. If you're using Docker, you can use either the Docker Hub, the official Docker repository, or you can create your own instance on premise, or you can use, again, Nexus or other technologies, or you can use maybe a private Docker registry from one of the major players such as Google, Amazon, and Microsoft. They all have offerings that include Docker container registries. So this is the entire continuous integration pipeline, and ultimately, at the end of that pipeline, your service, your component, your application, if it's a simple application, is going to be ready to be released because you have tested it and made sure that the quality that you had in that application before you made a change is still there. Nothing was broken. But of course, if you don't have any tests, if you don't have enough tests, you don't have the guarantee that after that code was merged and that feature was added on top of the previous functionality that you had, is going to be better, or is going to be the same, or is going to have the same quality. So testing is crucial in this process. That's why I said at the very beginning, having automated tests in place is key to be able to release fast and to be able to release with quality. Continuous delivery and deployment is taking that continuous integration flow or pipeline to the next level, because we might have changed the service, we might have changed a specific component, and we built it in a way that is ready for delivery, but we haven't done anything with it yet. We don't know if the service, when it's going to be deployed in the big application, in the big system, is going to be integrated with the other parts of the system properly. That's why what we need to do, therefore what we need to do is to make sure that we include that into our CD, into our continuous delivery strategy and pipeline. And of course, that implies that first and foremost, we are actually doing a deployment. We are sending our troops to war, so to speak. We are sending our services and our components and deploy them on the system where they can actually run and where the users are going to be able to use them. So if we build an application and we just build a package that encapsulates all the files and everything that we need to have specific to that application, just having that doesn't guarantee that the users are going to be using it, because it's not hosted, it's not running anywhere. Deployment takes that package and deploys it to a specific server and deploys it to or maybe multiple servers, depending on the type of infrastructure that we have, and ensuring that the users are going to be able to access that. Maybe as part of that deployment, we also need to create network elements such as or infrastructure elements such as virtual machines, drives, storage accounts, everything that comes to mind. Maybe it's part of that deployment. Sometimes it's decoupled. Infrastructure is deployed separately from the application, but we've also been using this approach where the infrastructure is being managed and updated along with the deployment of the application. And this ensures that everything is up to date. Your infrastructure is deployed every time you make a deployment. And this guarantees that when you're going to deploy it to production, you're not going to have differences and you're not going to have surprises. User acceptance testing. This is the only manual stage that is accepted if you want to have to be inside the continuous delivery pipeline. Sometimes you need to make sure that someone is actually giving in the check mark, is giving in the green light for a specific release. And it's okay to run certain stages or for some parts of your or for some functionality, to take that functionality through a set of users that are going to just look at your application and they're going to say, yes, everything is according to my expectation. Or maybe they're going to capture something that was not previously seen by automated tests and by manual testing. It usually implies or involves people from the, if you're from the customer or the user base that you have for, I don't know, beta access or early access or something like that. So putting their product into the hands of actual users can be a step that will be in an intermediate step between you having the application ready for deployment and doing an actual production deployment. Everything else should happen automatically. Even deployment to the environments where the user acceptance testing is done, and the deployment from that environment to the production environment once the release has passed the user acceptance testing should be automated. It should be a click of a button that then triggers the entire flow. But this stage, depending on your type of organization, depending on the type of your product, it might be important to be a manual step that is performed by you, like I said, by your actual users. Performance testing. This is something that can be done in parallel with the user acceptance testing. So while you deploy to the stage environment for users to review your application, you can also deploy to another environment where you start sending a lot of traffic, either to do a stress testing or to do a load testing, and to see whether or not your application breaks or blows in this instance, right? Is it going to, is it going to float? We build a boat, but is it going to float? Is it going to take water? Is it going to be turnover at the first wave, right? It's a metaphor, but actually suggests that when we are putting our, shipping our product, is going to be able to handle the load and handle the traffic that we are going to get from our users. Skipping this step leaves the application to potential errors when it hits the actual users. This is a stage of the continuous delivery process that needs to be carefully analyzed and then built in order to validate and to test the non-functional requirements specific to performance and have to be aligned with the user's expectations and with the scalability expectations. If you just build a test that is not relevant or is not going to help the users, then you should not have it. But if it's something that your users are going to care about, then you should put it in the performance testing suite. Security testing, same as with performance testing, needs to be done or can be done in parallel. So while the user acceptance testing is being done, side by side, we can also run performance testing and security testing, depending on how much infrastructure we have and how much we can afford, right? To make sure that we don't have security gaps in the application. Things, even if you start with something small, such as OWASP top 10, for instance, the most common security gaps that applications have or systems have, even if you're able to use the open source tools such as OWASP ZAP, that is allowing you to test those top 10 items against your application, those can be automated. Other tools can also be brought in. Some of them are more expensive, but automating the performance, the security testing can ensure that by the time you're we're ready to release, you really are ready to release, and you're not going to have security issues further down the road. In the past years, we've seen more and more companies and organizations being attacked by individuals who want to, get data and make money out of these security gaps. And we also have the new GDPR regulation, which enforces companies to invest and to worry about the security of the data, especially if that data contains personal information, right? You are, as an organization, are responsible for the safety and privacy of the data of your users. Therefore, you need to invest into security. Security testing is important and needs to be part of your DevOps strategy. Another practice that DevOps organizations are embracing is infrastructure as code. This means that we are no longer going to have applications and servers that are being deployed manually by people and are going to be maintained manually. And every time a server crashes, what we do, we try to recover it. We take it almost like we will have a pet. We will take it to the vet. Someone will come in and the entire team will come close, next, surrounding that server and trying to figure out what they can do, right? That's the pet approach. Instead, infrastructure should be almost like cattle. You're ready to sacrifice something when it's no longer viable. So you need to bring in a new one. If your server is down, drop it, create a new one, and everything should be back to normal, right? But that's not going to be possible if that server has been created, like I said, manually by people going into specific a data center, plugging in a server, and then trying to install operating systems and deploying various steps, doing a lot of steps manually. It might take days, even weeks, for a new server to replace a damaged one. Therefore, that's why many organizations are looking at those servers as, like I said, as pets. And funny thing, 25 years ago, when I started working in the IT industry, we used to have we used to name for our servers with actual, we came up with different naming structures, almost like Greek deities, right? Zeus, Athena, and when I used to be in college, every single server in the university had a Greek uh, god name, right? Why? Because they were maintained, and that was the name that the server was born with and is going to die with, and what they were basically never replaced. And that was the concept that even later I've seen in many companies. And knowing that concept, I also implemented by myself. So when I install new servers, I always try to come with new naming conventions, if you want, or naming strategies to make sure that I know exactly what the server is. Today, that's no longer applicable. We should not care or worry where the data is or where a specific functionality is. We should know that we have servers that do certain things. We have web servers, we have maybe DNS servers, we have database servers. How they are named and where exactly that server is it a virtual machine or a physical machine? We should not worry about that, right? And to be able to do that, we need to turn our infrastructure from being built manually, being built by humans, into infrastructure that is being built automatically based on code by robots executing code or applications executing code. Of course, that code, just like the code we write for our applications, is going to be written by developers, by DevOps engineers, but is not going to be executed only by engineers. It can be run by anyone, everywhere. And this has a couple of benefits. First of all, if your entire infrastructure goes down, you're able to bring it back again, right? You're able to recreate your entire infrastructure because all you have to do is to run that code again. Another benefit is that given that it's code, you can also take it through a code repository, source code repository, which means that you can benefit from all the good practices that developers have. Pull requests, code reviews, even static code analysis and other things can be applied on that code to make sure that you respect to the naming convention, you follow certain practices, certain policies that are established at the company level. When you work with VMs, with virtual machines that are manually maintained, or servers that are deployed somewhere and somebody needs to go in that physical location to maintain, you're not going to be able to do that. You have to go through a tedious and really complex process to get the same kind of information. Therefore, nobody's going to do it. But on the other hand, if you change your entire infrastructure, whether it's a network component or a processing component such as a VM, into a code that is being executed in order to be deployed, then you get all these advantages, and you're able to even go back to a previous state. You are able to go back to the previous code that you have in case something goes wrong. You can roll back. With infrastructure, that means you can you can go back and reset the state of the infrastructure quite easily. With traditional infrastructure, most of the time that means rebuilding the whole infrastructure again or changing a lot of that infrastructure. There are different tools, of course, in any technology. Even when we talk about testing, there are many tools that can be used and applied. Most of them are specific to the actual programming language or the actual technology you're using for coding. When it comes to infrastructure as code, the tools are, again, plenty. My personal favorite, comes from a company called HashiCorp, and it's called Terraform. I had another talk last year about this technology, and is gaining a lot of traction. And it's one of the most promising technologies when it comes to being able to turn your entire infrastructure and automate the creation of that infrastructure, no matter the type of application and type of infrastructure you're using. Of course, there are other tools such as Chef, Puppet, a lot of other Ansible, and a lot of other tools that are being built around these core technologies. We also have infrastructure as code technologies coming directly from different cloud vendors, such as, for instance, Microsoft has Azure Resource Manager, and you're able to build your entire infrastructure based on some JSON files and XML files and all sorts of templates, but they are really complex and they are restricted to be used in that cloud environment. Google also has their own setup, which is based on a Python scripting, so it requires a different kind of approach. Terraform is one of the technologies that is ensuring that you can create resources and you can create your infrastructure in many environments, right? So adopting the right infrastructure as code technology is key into establishing how your application is going to be deployed and where your application is going to be deployed. If you are going to be stuck forever into a specific cloud environment, that you can maybe use something that is specific to that cloud environment. But if you think that maybe you will need to scale, you will need to change your environment because maybe you will get a different offering, in terms of pricing, or you're able to scale better and easier at a smaller cost in another environment, then you might want to choose a technology that is allowing you to move your resources with ease. And Terraform is one of those technologies. Let's look at a couple of concepts that we discuss when we are talking about infrastructure as code. The first thing that we want to make sure that we are coding, we are converting from a physical or manually created resource into something that can be created as code is the actual resource, which means servers, databases, network components such as firewalls and load balancers and other items. All those are resources. All those are cloud or on-premise resources that we use in our applications and in our systems. And the first thing that we want to be able to script, to turn into code is those resources. So what we need to do is make sure that we understand, and we've seen earlier a diagram showing the infrastructure and also an architecture a view of some applications and systems that we have. And we need to be able to identify those resources from those diagrams and understand how they are going to behave, and also all the non-functional requirements associated with those components, how performance and how security and how availability is important, how important those are for individual resources. And then once we identify the resources that we need to look into the providers who can give us those resources. If we're talking about a computing unit, like a virtual machine, we can get that computing unit from any major cloud provider, or even on-premise hosting solutions such as VMware and Hyper-V. We can connect, because those providers, those infrastructure management solutions, have APIs. We can use, for instance, Terraform with their corresponding providers to deploy that infrastructure even on-premise. It doesn't have to be only cloud. So we can leverage many providers. Terraform and even other infrastructure management solutions have this concept of providers, so that you can connect to different cloud or on-premise systems and request resources there. You might also want to look into providers that are not necessarily in the traditional cloud computing space. You can even create Jira projects. If you're familiar with Jira, every time you deploy, maybe you want to create a Jira ticket or even a Jira project, or you may want to push something to a Kubernetes environment, or you may want to push something to a Docker registry. So there are different platform as a service, infrastructure as a service, and software as a service providers that, through their APIs, they give you access to their resources. So you can create with Terraform, for instance, or other similar technologies. You can create the resources in those providers. And Terraform provides, or IAC provides usually the unified language, the unified structure in which we can get those resources and even connect them among themselves. To give you an example, you can create a DNS record into Amazon Route 53, which is a DNS management service from Amazon. And then that server or that DNS entry is going to point to an IP address that was created with either in OpenStack or in Google Cloud Engine or in Amazon Web Services or in Microsoft Azure. So you manage the DNS into one system, and dynamically because those resources are going to be connected. Whenever the machine that actually runs whatever application you're running is going to be redeployed and change the IP, the DNS is going to point to that. This is particularly useful when you want to have, for instance, domains that are mapped to certain servers, but those servers are not always up and running. So you might have a process that is, you click a button, some machines are being created, you don't worry where they are created, you don't even worry how they are running. All you know is that at the end of the process, the specific domain that you have given or subdomain that you have given to that application is going to be available, right? And even if it's not part of the same provider, this is possible. Another concept that is important in infrastructure as code is the usage of workspaces. And this is particularly useful when you use multiple environments for an application. So you have development, you have testing, you have stage, you have automation testing environment, you have maybe performance testing environment or security testing environment, and then multiple production environments. You may want to keep the state of different, even if you use the same infrastructure as a code foundation or the definition, but the actual state and the actual level of setup has to be kept separately between those environments. So in other words, you make a change and you want to deploy it first to the development environment, you validate that everything is fine, and then you roll it out in the next environments. And this is where workspaces, being able to separate your work into different workspaces comes in handy. And that is usually combined with another concept called state and backend, which is basically allowing you to capture the state of your current infrastructure. So the actual resources with the references into the cloud system, into maybe a single file or a single repository, so that every time somebody else comes in and wants to make some changes, it applies those changes on top of the actual application state. And then if something was changed in the cloud environment or in the at the provider side, there is going to be a difference between what's there in reality and what's in the state, and then the infrastructure management, such as Terraform, is able to identify and is going to be able to warn you about changes that have been occurred. So you need to manually address those kind of differences. And this is particularly useful when, for instance, you have situations where something really bad happens and you need to make a change into a production environment, but then you forgot that was done. When you try to make a change on that production environment, it can be retrofitted back into your definition, because it's going to see that you have new resources or resources that have been manually altered, and then you need to manage that. So basically, your state is the moment of truth, and this can be or is not the moment of truth, but the place of truth or source of truth, and that is also something that can be captured or stored in what is called the backend. To give you an example, it can be stored somewhere in the cloud, so that multiple engineers, multiple DevOps engineers are going to be able to make the changes to that environment independent from each other. So you don't have to be on a specific machine in order to be able to do that. You can do anywhere, because you're still going to be able to look at that source of truth and make sure that the changes are done accordingly. So you have the state, but you also have the source code, and then this gives you full power into managing the infrastructure. Another concept is data sources. So we talked about resources, and we know that we can create any kind of resources that we want into a given environment, but sometimes we don't have the luxury of creating all the resources by ourselves. There might be shared resources, or there might be resources that are created by other people with more permissions than we have, or resources that should not be altered. For due diligence, you don't want all the resources to be given to a specific team, and then you will just want them to be connecting to those resources. And Terraform and other infrastructure as code technologies allows you to define a data source and a resource basically that already is supposed to already exist in the environment that you're connected into the provider, and then you're just connecting to it and consuming whatever information and properties you have about that resource. This comes in handy when, for instance, you have to give you an example, you want to create a Bastion or Jambox machine. This is a concept where you create a virtual machine that is highly secured, is hardened, so usually has multi-factor authentication and other things implemented, security elements. And then that machine will have an IP address. And that IP address is being allowed to be connected to other systems. But sometimes you don't want to keep that machine always running, because it doesn't make sense. If you don't need to access other systems, and given that you are able to recreate that machine with infrastructure as code in 5 minutes or 10 minutes, it doesn't make sense to keep that resource going, because that's going to just cost you money. So what you can do is you can, like I said, recreate that machine, but use the data source to make sure that you always reuse the same IP address. Because if you lose the IP address, if you change the IP address, then you're no longer going to be able to connect to those machines. So by registering and locking that IP address, pre-allocating it and using it, it allows you to be able to connect it to or attach it to a specific machine at any time. You could, using the data source concept, connect to and do whatever you have to do on the target systems, because you are able to use that machine and that IP address, and then you can shut it down. And this is a simple saving exercise. And if you think that maybe a VM goes 20, 50 euros per month is not a big saving, but think about this concept being applied to entire environments. When you work with on complex applications that require complex infrastructure, where you have maybe 10 servers, and maybe you have different databases, managed databases, whether it's a SQL Server or MongoDB or whatever that you're using in your application, and being able to shut down everything, even overnight and or over the weekend, gives you tremendous savings. Combined with other vendor-specific savings and plans that you might have, you can have up to 70-80% of savings. We had a project recently where, by applying this concept, we saved for maybe 8 months of the development. We saved the customer more than 10,000 euros per month by making sure that we created the infrastructure only as needed. So if you think about the long term and the scale of your application, using infrastructure as code can help you save incredibly a lot. It can help you save a lot of money, and you can use that money to turn it into development and to build more features and maybe make your product better. The last concept. One other concept about infrastructure as code is dependencies, which means that one resource can depend on another. And Terraform, for instance, has a nice way of identifying the dependencies based on information or properties that you use in one resource related to another. But you can also specify those by yourselves. And this means that it's managing the entire resource deployment process in a way that resources that require information from another resource are going to be wait quietly and nicely till that resource is going to be made available. And then, for instance, you want to make a server that has access to a database. And what you do is you create the database first, you create the server, and then you can create a network security group that it's attached to the network, to the database, and the IP address of that server is enlisted into the network security group. So many different situations where having this dependency managed for yourself is extremely valuable, and it can help you create your infrastructure without having to put to build scripts that are waiting and trying connections. Everything is handled for you automatically. And I believe this is going to be the last concept about infrastructure as code is the provisioners. Sometimes you will get, when you create a resource, you will get an empty resource, maybe an empty virtual machine based on the flavor or the image that you want. Maybe it's Ubuntu or Windows or other flavors of Linux that you care about. And after that VM has been created for you, you can you can install different software packages and make sure that that VM is ready to be used using those provisioners. And provisioners are usually allowing you to transfer files and to execute different commands and to perform operations directly on that machine. And once the provisioning process has completed, the VM is ready to be used, and then you're done with your setup, and the application can just be deployed. Okay, another concept and another practice that is key in today's modern application is containerization, and namely using Docker. Docker is a technology that allows us to move from the concept of packaging applications in virtual machines and images that are really large, usually in terms of tens of gigabytes of data, because they encapture the entire operating system and all the dependencies and all the software that we need, into much lighter containers that are basically leveraging just the different layers that the applications requires. Files that are required for our application to run on top of an existing image. And the image that every container uses a specific image that is actually, like I said, identified by a number of layers containing different files, different changes from the previous layer. And this allows us to make sure that, for instance, when you have application that is using the same operating system, the same libraries and dependencies, our images are going to reuse maybe 95% of that shared, if you want, dependency code or libraries or files, and just add a thin layer of just what we added into that application. So when we create a container, downloading that application, downloading that image is going to be extremely fast, because assuming that we already had another container deployed based on the same base image, we are going to be able to download it in seconds, because it only downloads a couple of megabytes worth of our, what our differences are, and then start it in another couple of seconds. So compared to the setup of virtual machines, where deploying a virtual machine to another environment means you have to transfer maybe 50 or 100 gigabytes of worth of maybe an archive, and then unpack it and then deploy it, which is usually taking 20 to 30 minutes to get started, is extremely slow. With containers, you can get all that running in a matter of seconds. Even if it's a large image, and if you're containerizing Windows applications, those images are actually going to add up, because even if it's using Windows Nano Edition, that is still close to a gigabyte worth of data. But if you have a setup where multiple applications are being deployed, that image is going to be shared between maybe all your services, all your applications, and then it's being downloaded only once. And if it's a Windows environment, chances are that it's already going to be set up with that image by default. So whenever you install a new application, it's going to be adding that particular, just the additional layers, just the additional files based changes that you had in your application. So going back, and when we look at the benefits, I think it's clear that the first benefit that Docker provides is the ability to deploy applications really fast, because we no longer have to package a lot of dependencies in a heavy image distribution way. But you might ask yourself, why not work with just installers or other thing? You can still use installers if the installers are going to be used by your end users. But if you're supposed to be delivering working services, you expect something that when you ship is going to be brought up really fast. And why? Because we just mentioned a bit earlier that infrastructure should not be a pet, should be a kettle. And Dockerization allows us to say, okay, if the application fails and whatever instance is running, we can drop that and we can create a new one without worrying about what happened to that one. Okay, maybe we worry about it by looking into the logs, but not inside that container. So containerization allows us to make sure that we bring the applications really fast, and we make sure that we don't worry about the infrastructure too much. And another huge benefit of packaging application with Docker or with other container technology is that we can embed all our dependencies with the actual application, with the actual service. So, things like it works on my machine should never happen again, because once we have packaged the application or the service along with all the dependencies and we shipped it to a repository, wherever that image is going to be used, whatever environment, whether it's going to be another developer's machine, or it's going to be the development environment in the cloud or production environment, we are going to be able to run the exact same service in the exact same way, and it most likely is going to work exactly the same. Also, using Docker allows us to be given that given its wide adoption, allows us to make sure that we are going to be able to deploy it in environments that we are not currently aware of. Previously, we had to make applications differently for Windows and then for Linux, and different flavors of Linux having different maybe versions of Java installed or whatever. It was quite a bit of mess to manage all that complexity, and Docker simplifies it. All you have to do is make sure that you have Docker installed, and then you can deploy any application on top of it without worrying about anything else. So even traditional infrastructure people will accept that it's much easier to provide an environment that is Docker ready to developers and just allow them to deploy applications, restricting and making sure that all the security and performance boundaries are in place. So it's much safer even for traditional IT guys than to give them access to a server where they can go crazy and do whatever they want there, because the applications, every Docker container is going to run in isolation. So adding a service and running some functionality inside a container is not going to impact the rest of the containers that are running on the same machine. In terms of networking, Docker and containerization tools such as Docker Swarm or Kubernetes has a really nice functionality associated with networking, allowing us to define different subnets and isolate different services based on those subnets. So the services can work in isolation and make sure that one application is only connected to the services, or one service is connected only to the other services that are strictly needed, to make sure that in case the service is being hacked or there is a security issue, the rest of the application is not impacted. So even if servers are actually running on the same machine, because of the network segregation and the subnets created as part of the Docker deployment, Docker Swarm deployment, or Kubernetes deployment, services are not going to be able to connect among themselves. So security and networking are really giving us a lot of support. So the Docker gives us a lot of support from the security networking perspective. Configuration, both in Docker Swarm or Kubernetes, two of the orchestration technologies that are popular for Docker. We have really good configuration support, allowing us to transfer information and manage that configuration in a centralized manner, and then just pass it on to the services. So even if we create a new service on a new node, we don't have to worry about configuring that service. That configuration is going to be taken, let's say, from the centralized configuration repository. Same thing with more sensitive information. We can create so-called secrets. They are encrypted. They are stored in secure locations, maybe using a technology such as Vault, another good technology from HashiCorp, and or similar technologies, of course. And then those tools allow us to encrypt the sensitive information, so that even if a malicious user is somehow getting access to a container or a service, that information is not going to be exposed, such as credentials, certificates, and other things. The last important aspect of containerization is what is called orchestration. So we have containers, which are basically just instances of different images that we can run, like instances of services, instances of applications. And with orchestration, we can make sure that we bring together all the configuration, all the networking, this relationship between services, and we define them as a whole. We create a simple orchestration plan that says how many instances from each service is going to be available, what are the services and the ports that either that service exposes or has access to, all sorts of small and granular things that can be applied at the entire infrastructure level. And then with container orchestration, we can make sure that whenever an application is, for instance, requiring more load, we can simply increase the number of replicas, the number of instances for that application. And inside that orchestrator, inside the Docker Swarm or inside Kubernetes, that service is going to scale automatically to the number of instances that we have. Okay. Not everything is, peace and honey and all those good things that we can think about. Not everything is just peace and love. There are challenges in the DevOps world, and most of the organizations have to be careful about embarking on this path because they think that jumping into this train is going to take us to success, but they don't think about the implication and the challenges. The first challenge is the complexity. I've been talking for like an hour and a half, and I've been mentioning an incredible amount of technologies and practices and concepts that a DevOps organization needs to understand. So is it really worth it? My advice would be, or my answer will be yes, but depends from organization to another. Definitely, what you want to make sure is that you don't try to do everything at once. Another challenge is the initial cost. To get started and to get embarked in this approach, you need to understand that you're not going to get savings from day one. In fact, initially, because you need to bring more people maybe, or change their responsibilities or derail their focus, things are going to look more expensive. Or you maybe need to change to add more infrastructure, different infrastructure than you previously had. So you need to be prepared to have an initial cost associated with this direction. Of course, you need to have the proper skills, and sometimes this can be a challenge. There are many organizations that are trying to switch from a traditional operations and development organization into a DevOps organization, and it's extremely hard because IT and ops engineers or the regular operators are not going to jump into this train easily because they lack a lot of the knowledge, but they have most of the knowledge, but they might lack some of the knowledge that this implies because they were not used to those practices. So pushing this from the ops side can be problematic. Pushing this from the development side is also going to be problematic because they don't always have the know-how and the skills specific to infrastructure. Most of them don't, or most of us don't, right? And then how do you start? You need to bring those skills by making sure that's why I said earlier about the mindset and the culture, because you need to bring all those people at the same table and make sure that they work together as a team. And then if that's self-organized, it's not another department that does this and throws it over the wall. I'm part of that team and I'm working with that team. And maybe I bring more experience to the table from the ops perspective. I have another developer in the team, a colleague that is a senior developer and knows a lot about architecture and other things. He will explain things to me. I will explain things to him, but we are going to work together. I'm not DevOps if he's not DevOps. If I'm an IT network or infrastructure engineer and I'm joining a development team, I will keep being an IT or infrastructure engineer till the moment where everybody in that team is DevOps. I might be lucky and I might be able to catch up a lot of information fast, but only if everybody's joining this effort, the skills are going to be spread across the entire team uniformly enough to be able to support the DevOps approach. Tools. There are many times we need to adopt different tools to be able to embark on this path. And some of them are open source, some of them are free, some of them are commercial, some of them might be quite expensive. And this all depends on the strategy. And ultimately, you can always start with what's available on the market. You can have experiments and you can get open source or free software, and only move into the expensive ones that when the need actually occurs. And once you get to know the value, and you reach a certain state in your maturity towards DevOps, that cost is going to be justified with absolutely no question, or might be justified. If it doesn't, then you don't need that tool anyway. So tools from the cost perspective, but also from the multitude of tools that you might need to get familiarized with and understand and put together. This contributes to the complexity, to the cost, and other things, but it's also it can become almost like a pain for the entire team with the multitude of tools that can be used. That's usually at the beginning. After they are familiarized, after they're used to that, it's really easy they become just tools that you use, and it's almost like you feel like, why haven't been using this before? Existing culture. An organization with a toxic culture, with the mindset that it's the developers or it's the ops, it's their fault, a blaming culture, or an organization with a culture of blaming others for our faults, is never going to let DevOps succeed. What you need to have instead is an organization, or to move towards an organization where you accept the fact that sometimes the proverbial should hit the fan, and when that happens, you bring the entire team and you figure out, how can we fix this, and how can we make sure that it doesn't happen again, and everybody does their part. If all you do is try to push the responsibility to others, then chances that DevOps is going to work are zero, or almost zero. What do we have to do as an organization to embrace DevOps? The first thing we need to do is to look where we are, understand how many of the many things that I mentioned, and most likely I missed a few, how many of these things do we do? How many of the practices do we already have? Maybe one project or one developer is already doing some experiments with maybe infrastructure as code, or maybe with unit tests, or maybe with Docker. Let's try to figure out across the board, in all the projects, in the entire organization, where we are in terms of the practices and the tools and the principles and the values and everything else that DevOps means. And there is a simple tool that we can use for that. It's called a continuous delivery maturity model, because ultimately the whole DevOps mindset is created, or is meant to be focused on fast and quality-based delivery. Everything is based on delivery. Everything is based on ensuring that our products are shipped in front of our users. We don't do DevOps and we don't do development for the sake of doing development. Some of us do for fun or for hobby, but we build products so that they end up in front of our users. And that's why the focus should be on delivery. And this metrics shows different stages and different levels of maturity that you can have in your organization, and different areas, things like culture, things like design and architecture, building and deploying, testing, integration, information, all those things, right? You can segment your organization in different stages, in different areas, and then evaluate the maturity level for each of those areas and understand exactly where you are. And then try to set some realistic and idealistic objectives. Why both? You need to set realistic so that you know what you can count on, you know what you expect, and you make sure that everybody is there and working towards that goal. But you should also be setting some idealistic, some really high objectives. And why? Because, and this is one of my favorite quotes, it says, only those who will risk going too far can possibly find out how far one can go. This is beautiful, because when you stretch yourselves, or ourselves, only when we stretch ourselves, we can find out how stretchable we are. Only when we try to push the boundaries, we can actually see the boundaries. If you're happy with just moving the needle just by a little bit, yes, we move the needle, we are successful, but are we truly doing our best? So setting good enough expectations is good, but setting some visionary expectations it's also helping to bring everybody on board. I give you the example with the organization that I set the idealistic objectives to have 10 releases per day. That's not done even today. But if I will have set expectations that rather than 2 years to release every year that product, would that have turned the organization around? Would that have changed the way the mindset of the developers and the entire team and the entire organization was around that product? No. We had an improvement, but improvement is not all. The mindset associated with that improvement is key. And sometimes to build that kind of mindset, you need to set some stretching goals. Once you set those goals, which might be high or small, depending on where you are and where you want to be, you need to start small. And this picture shows, picture speak 1,000 words. And I think this one speaks by itself that, the start is extremely important. And if you see what the runner has in his hand, you probably figure out that this is a team effort. It doesn't count how fast you can run if at the end of the day the results of your team are not good. If your team is not cohesive and it doesn't work together properly. So it's a team effort, and you start small and you focus on that team effort, and then results are going to show. You need to prioritize. You need to keep a balance between things. Sometimes you still have to deal with everything that you have, legacy, everything that you have in your existing organization, all the other challenges, and it's okay. Everybody been through that. Balance and prioritize what you can do, and eventually you will still do, and you will still make progress. And it's important that you improve every day. It's important that you improve on top of what you have built or what practice you have adopted. Don't give up on the first failure. Improve it constantly, because 1% improvement every day for a year makes you almost 38 times better at the end of that year. So I made another calculation. Even if it's 0.1%, you're still going to be almost twice as good at the end of the year. So improving by a fraction, spending minutes or hours per day towards that idealistic goal will get you faster, will get you closer to that objective. It might not be tomorrow, but you will eventually going to get there.
Innovation Days is part of the Future Skills lifelong learning program. The project is co-financed from the European Social Fund through the Human Capital Operational Program 2014-2020.